question that is given in this description, you can say is world class. It's the best type of question. You read the question at your ease. I will allow you time on this. The problem with the question is you do not easily figure out, you cannot easily figure out how to enter into this question. There is a function, domain open interval 0 to 1, and range is all real values given as fx. But fx, amazing situation here, a function of x, a function whose domain variable should be x, is described in terms of n. Now, this is the first point where your conventional mindset will get struck. You will be literally shocked. Fx equal to root n, and then x is element of, now look at this closed interval 1 by n plus 1 till 1 by n, and n is a natural number. It's like 1 by 5 and 1 by 6, from 1 by 6 comma 1 by 5, and this type of a thing. Wherever is n as a natural value, this is the set of variation of x. And when x is varying like this, say for example from 1 by 11 comma 1 by 10, then your fx value is going to be root 10. You can understand the mapping of the function by this, but using it for derivatives would make it extremely difficult. For limits, it is impossible, and that's what makes this question very nice question. And this is the type of a question which intrigues your mentality, and which penetrates your classical set of ideas and shakes you up in the exam hall. My first suggestion here would be, if you ever see something which does not go as per your classical traditional mindset, just sit straight, take a deep breath, read the question, and find out where is that problem really going to become relevant. This is the first question. Is this functions everything relevant to this question? Answer is no. There are only a few things of this function which is going to be relevant here. Now let's go ahead. This particular g function with a domain 0 to 1 open interval, I know you can see everything, but still I am going through reading, because this g function has not been exactly defined. You see, this has been given with an inequality. Now that's where the problem is. You do not know what is g of x, and you need to calculate this. So if I want to make a point where this entire thing becomes related to each other, I mean to say the relevance of the function fx and the g of x with each other. Now this is how it goes, dear. If let me add, if you have not gone through the solutions of this question ever before, and if this is the first time, then you need to listen to me precisely, clearly, with deep focus. Stay tuned. Now see this. You need to calculate this thing with this condition. The limit x tends to 0. Now let's come to this situation. If you say that x is tending to 0, and then if x is tending to 0, then what is going to happen to n? Given that x is element of 1 by n plus 1 comma 1 by n. Now if x tends to 0, that means your n tends to infinity, and then n is approximately equal to n plus 1. They are not much different. And then how are they related? How are they related to each other? That means your x is 1 by n. Straight cut, this is a relation that you can use, that you can exploit, and that means your fx, and that means your fx. This means this, and this means your fx, which is equal to root n, can be alternately defined as 1 by root x. I know there are many more possibilities about x and n relation, but this is what directly comes to your mind because of this description. X is element from this fraction to this fraction. That is all. 1 by infinity plus 1 till 1 by infinity. 1 by n plus 1 till 1 by n. You can have both of these value very near to each other when n tends to infinity. And therefore I am saying x equal to 1 by n. Because this is all happening at infinity. This is the biggest thing which you should see right at the beginning. The moment you then obtain fx into g of x, now you see fx dot g of x description shall be multiplying the g of x values or inequalities of g of x with 1 by root x. So this would be like, g of x by root x situation. This is what is going to matter now. This is what is going to become relevant now. Now see, if you want to obtain this, that means it's not dividing by root x on both sides of the inequality. So, I am dividing by root x here, dividing by root x here. And in that case, the inequality from x, integral from x square to x with a root over 1 minus t by root of t dt less than g of x less than 2 root x. This is all going to get divided by a root x. Each of them going to get divided by a root x, and this is fx into g of x. So after this division, as you can see, the right side is cancelable, and this is what you need to calculate as fx dot g of x. And the moment you say that you have to apply limit x tends to 0, so we are going to apply a limit x tends to 0 on all the terms of inequality, and this is what it becomes. That means effectively the question becomes limit x tends to 0. This question can be alternately written as limit x tends to 0 on this description and limit x tends to 0 on fx into g of x, and this is a straight cut too. So our responsibility is to solve this. Now when you see this limit x tends to 0 applied to the numerator, the lower limit of the integral 0, upper limit of the integral 0 builds up 0 in the numerator and 0 in the denominator. This leads to the L'Hopital's rule, and the L'Hopital's rule would require us to differentiate the numerator and the denominator. Now differentiating the numerator would require the Newton-Leibniz rule. The Newton-Leibniz rule for derivative of the integrals. So let's do that. Now derivative of the numerator, that would be root of 1 minus x by root x into derivative of x, which is 1, minus root over 1 minus x square by root x square, means mod x, and here x is greater than 0 and going ahead of 0. So I am talking in the region from x equal to 0 plus till x equal to 1. So therefore I am talking in the positive side. So here this mod x is going to be as good as x, and this is about the numerator. Oh, just a moment. Now root of 1 minus x square by root of x square, which is mod x, equal to x into derivative of x square, that is 2x. This is derivative of the numerator. Now derivative of the denominator, ddx of root x is 1 by 2 root x. Now if we simplify this, then root 1 minus x by root x minus root of 1 minus x square by x into 2. This x is going to get cancelled. This x cancels, remains a 2 here into a 2, and this is the numerator into 2 root x into 2 root x. This is going to give you now 2 into root of 1 minus x, this thing into this thing. Root x cancels, 2 into root over. Now minus 4 into root x into root of 1 minus x square. This is the solving. And now when you apply limit x tends to 0, when you apply the limit of x tending to 0 on each of these, when you apply this limit x tends to 0, your answer is 2 and 0. So therefore this is going to be 2. Now that means this entire solving of the limit is of value 2, and therefore you can fairly say that this exists between limits on this side 2 and on this side also 2. This 2 is the solving for this entire calculation, which brings in this 2. And therefore, when limit x tends to 0 is applied, both sides yield 2 by sandwich theorem. Therefore, by sandwich theorem of the limits, we can say that the limit x tends to 0 fx into g of x is going to yield an answer 2. This is going to be the answer of this question. Thanks for your patience. I hope you must have enjoyed this. If you have not enjoyed this, then prepare yourself for the subject of maths. Thank you for your patience and see you in the next question. Stay subscribed.